So today we're going to take a look at two separate learning targets. The first, I can describe the system as consistent and independent, coincident or inconsistent. And also I can name the solution or solutions of a system given the graph. Look at that first learning target. So what do we need to know? We have our little graphic organizer here of the types of solutions that you might see when given a system. So the first scenario is when we have a solution, when our two lines intersect one another. In that situation, remember, our equations have different slopes and different y-intercepts, and when we describe that system, we say that the system is consistent and independent. When we have a situation where our lines do not cross or intersect, those are parallel lines, and there are no solutions. Our equations have the same slope and different y-intercepts, and when we describe that system, we say that that system is inconsistent. And then lastly, we have our situation where we have the same line. That's when we have an infinite number of solutions. Those are the same slope and the same y-intercepts, and we call those coincident or dependent. You might see both terms depending on the context. So in this first example, it says to describe the system of equations. So notice I'm given a system already graphed for me. We're going to use our graphic organizer to determine what description matches this scenario. So since I have two equations here that clearly intersect, they have a solution. The terms to describe that specific situation where I have a solution is consistent and independent. So you're just matching your solution set with the terminology to describe that system. So since I had a system here where they cross or where they intersect, that's one solution. When I describe it, it's consistent and independent. Right now, go ahead and pause, come back after you've tried to check your answer. We're also describing the system of equations here. Notice in this example, I have two equations that do not cross, so there is no solution. They do not intersect. And my terminology to describe this system is inconsistent because the lines are parallel. So sometimes instead of asking to describe the system using the terminology, sometimes they might just say, what's the solution to this system? So here I'm given two equations, but notice they're already graphed for me. I don't need to go ahead and graph them. They've already been given to me. I have a red equation that you can kind of see underneath here, and then my blue is dashed. So clearly here they're overlapping. So when we look at our graphic organizer, when I have those two graphs or two equations that overlap, that's an infinite number of solutions. This would be a great time for you to pause and then try this one and then come back and check. Again, it asked me for the solution to the system of equations. I've already been given the graph. I do not have to graph it. I see here clearly that these two intersect one another. So we have that solution. Then I just have to go over and look to see where that solution is. So clearly here on the x-axis I went over 2 and then I'm going up 1. So my coordinate -2, 1 is the solution to this system of equations. If you need more information on this topic, check out the Learning Target spreadsheet for additional resources, videos, and practice. Thanks for watching.